Good afternoon. Let's get started with today's agenda. First things first, many of you have asked me if you can access the slides. All the slides, and in some cases the videos are online. You can go to the website of the Energy Institute. This is the address, energy.utexas.edu. You can find the symposium link at events or under courses. You could also just search UT Energy Institute online, and you'll get to this link. Let's see, for the students, just a few minutes ago was the deadline for your first research notes. I have received it, hopefully, from most of you, all of you. If you have not sent it to me, you are in trouble. So come talk to me after the class. I sent out five emails to you guys yesterday, promised I will send sixth one. Could not get to that, but I'll do that over the weekend. It's an important note that I really want to get to you guys. For those who are wondering what I'm talking about, this is a forum open to the public, but also a class, so people can formally register for this class. This sheet will go around. Please make sure you sign in if you want to receive notices about future events. Let me tell you who our next speaker is going to be. It's Geborg Sargsyan from the World Bank. He is the program coordinator for the climate investment funds. He is a really, really important key person. He manages in what I believe is the only real fund for climate change investments internationally. It's a huge fund, $6.5 billion. And he has been managing that. He has first-hand real experience of what the mechanics, what important things are, and he'll be here to share his experiences on that front. So please join us there. I really have to thank you guys for coming every week. I know the word is getting out, more people are getting involved, and one good evidence of that is I received an email a few days ago from a plumbing company that says, please take me off from the list. So we are certainly able to reach out to a much wider audience. With that, let me introduce our speaker, Dr. C.K. Wu. Dr. Wu is the senior partner at E3, that is Energy+Environmental Economics. It's a consulting firm based out of San Francisco Bay Area. He has 30 years of experience in the industry. He's published over 100 refereed journals. He has been very active. I'll have a little more to say about that. On areas as far-ranging as applied microeconomics, applied finance, energy economics, on all sorts of energy issues. He is an associate editor of the journal Energy, a member of the editorial board of the Energy Journal, and also been a guest editor for a special issue of Energy Policy. These are all, as many of you would recognize, very top-rate journals. So I said I'll share a story. This is a story that I have not verified with CK, but Jay told this to me maybe several weeks ago, and the story goes like this. They were having a discussion. CK came up with an idea, and he wrote a paper in 2 days that was submitted and accepted within just a few days at a top-rate journal. So if you're stuck in writing a paper with your ideas, with your PhD thesis, that's the person. He really can churn things up. In his previous incarnation, he was also an associate professor of economics and finance in Hong Kong, and has lectured widely, worldwide, and testified before several public utility commissions on issues related to the electricity industry. He holds a PhD in economics from UC Davis. The title of his talk is Wind Generation, Development, and Incentives for Dispatchable Thermal Investment. With that, let's thank our speaker.
Well, Professor Raj, thank you for having me here, and certainly, well, thank you for coming. A lot of times my talk will have just a few people attending. Today is an exception, so thank you. So, what motivates my talk? You know, I'm an old geezer, so remember the Bob Dylan song. So, can we really say to have a clean environment, the answer is blowing in the wind? Well, not so fast. You know, it's like, you know, in that TV program, Curb Your Enthusiasm. I have a couple questions regarding this talk. So I always try to focus any type of paper I write or any type of talk I give, pose it in a fairly direct question. Think about it for a moment. If there's a lot of wind generation, and we know that wind generation can be high or low, it's an act of God, depending on wind, whether it's blowing or not blowing. So given this random as available fluctuating wildly output, to make use of it, you need to have some generation backup. It's called dispatchable generation. It's like you have an old car. It might run, it might not run. So what do? You want to have a little car as backup. So now, then the next question is, well, if there's no incentive to buy the little car, there's no money for it, what can be done about it? So these questions are very timely and important for a number of reasons. One is the Bob Dylan song, the answer must be blowing in the wind. Is it true? Then the next is, wind energy really is seen as the magic silver bullet that will cure our environment problem. Just think about this for a moment. If all the generation, thermal generation, especially coal-fired generation, can be removed by wind generation, shall we reach the clean energy utopia? So a lot of people think we can get there. And I'm somewhat a skeptic. I say, not so fast. So I never like this type of slide agenda. It's a giveaway, So let's move on. You kind of like space filler. You need her 20 slides, so put one in. We all know what's coming. So to summarize the result, because I'm an economist, so the only thing I know is to run into regression. And I look at the data coming out from ERCOT and look at it and say, how much wind generation one must inject into my little regression model before I see an effect of wind capacity that will reduce investment incentive. So it turns out that 10–15%, there's no statistically significant effect. But once it reaches 40%, it matters. And the result, turns out that, it matches pretty well with the result that found for Germany. And they did a totally different way of obtaining their result. What they did is they built an engineering simulation model and a big, huge dispatch model, and then play around with the wind generation and say how much wind generation must enter into the system before you see significant change in the profit to be earned by conventional generators. Oh, by the way, if I'm too fast, let me know. If I'm too slow, let me know. I can accelerate and decelerate, just like a dispatchable generator. So what's the policy implication? Well, suppose that there's a decline in profitability for the dispatchable generator, then how can we induce them to invest? Kind of like the Wendy's commercial, show me the money. Well, actually, Jerry Maguire, show me the money. Or where's the beef? Show me the money. So one way of dealing with this problem is a capacity market as done in New England and New York and PJM. Or you can have bilateral contracts. Let's say a company like Austin Energy, right, and sign up with some contracts with some generator and say, will you kindly provide capacity at a very low cost or low price? Yeah, it's negotiable. Or for that matter, maybe like, Austin Energy can just own it directly. Or better yet, put the responsibility back to the wind generator. You go find your own backup. So these are some of the possibilities. How will they work? Well, I haven't figured it out yet because this is an ongoing thing, and I haven't done any particular deep research in it, so I'll be stupid to venture any particular answer one way or the other. But certainly, all these are in play, and how they turn out is all depending on how you structure the deal. So for those that are not familiar with the electricity market, that might be useful to give a little background. When we have a competitive generation market, market prices are extremely volatile. It is the most volatile commodity in the world, more than anything else. You think gold price is volatile? No. You think oil price is volatile? No. But electricity price can double, triple within a day or two. You don't see that in any other form of commodities. Why is that? Well, everything bouncing around. The input costs change daily. Weather can do a lot of bad things to you, hot and dry. That will drive up demand. And if you have limited capacity in the market, price just spike very fast. And we all know that electricity cannot be stored. And of course, equipment can fail. And a lot of them, one might argue, why can't supply occur overnight? Well, try to build anything, especially in California. Just the permitting process will take you several years. And of course, there's bad boys out there, strategic bidding. So what do you mean by strategic bidding? Think about this for a moment. If the market price determination is based on individual suppliers' bids, how can you make money? I'll tell you how to make money. Let's say I have 5 units. I'll bid one low, I'll bid one, okay, not so high, maybe based on my cost. Then I'll bid one very high. The reason, I might get lucky. If I get lucky that day, all my units will be paid at high prices. So that's strategic bidding. Now, then the next question is, why is it so successful? Because there's a coordinating factor going on. It's called temperature. Everybody can observe temperature. Everybody knows temperature forecast tomorrow. So you practice strategic bidding. You don't have to do it every day. All you need to do, your buddy will do it every other day. So you cannot be caught as a bad boy. So there are 2 main areas of research. There's the electricity finance. So electricity finance, you talk about all sorts of things like pricing derivatives, price behavior, and I don't even know a lot of those, econometrics, Gauge, March model, I don't know. And then you have risk management. And as far as the electricity economics, a lot of that research focused on how to design a market. For example, the electricity market in Texas is an energy-only market, meaning that people sell into the wholesale market. They only pay for the amount of energy that put in. There's no capacity. There's no capacity meaning you cannot contract for just the engine of the car rather than the miles that travel by the car. So, and along with that, there's the capacity adequacy discussion. What if everyone just get paid by the miles that you travel instead by the size of the car? Would there be enough investment? The answer is still up in the air. But the reality of that is that investment has been slow in markets like the eastern market. As I said, PJM is Pennsylvania, Jersey, Maryland. New England, that's like the whole New England states, not just Massachusetts, but the surrounding little states. And also New York. They don't have enough capacity, so they will payment, not to run the car to travel, but just to have a car available in case the system operator needs it. So my concern is that if generation investment incentive in the energy market depends on high prices, well, life is good if prices are high and sustained. Yeah, sure, I'll invest. But what if wind generation comes in and suppress wholesale market prices? Will I invest? Probably not. Then the next question is what to do about it. So this is a little picture that I borrow, and all it says is when you have wind generation coming online, wind generation is free in terms of there's no fuel cost. So what do? You push supply curve out, and you just suppress the output prices. So there's a paper out there and saying that for every % increase in wind generation, that will suppress price by 1%. That's quite remarkable when you think about it. If there's 10% increase in wind generation, that means the wholesale market price will come down by 10%. When the profit margin in generation is very thin, basically everyone is done. Nobody wants to invest. So does that make sense so far? Little pointer? No. Really? It's okay. I make the job tough for the recorder. Start doing a little dance. So ERCOT is quite remarkable. Yeah. Comparing to a lot of other countries, ERCOT is extremely large wind generation as part of its total generation fleet. Why is that? Well, it's just you got a lot of wind in West Texas, and more importantly, there's a tax credit going on, and very friendly interconnection. So in order to make money, a wind generator needs to first is connected to the grid. It costs too much money. That's no good. But tax is cheap. Actually, I think it's free almost. Quite remarkable when you think about it. Texas is the big winner in the US. So California is not even close. So I always thought California has a lot of wind generation, and obviously Jay proved that I'm wrong. How about, as a percent? Well, that's pretty decent. It's almost 10%. So, and that sets up, the really big issue. You already got 10%. What if it becomes 20? Can the system handle it? How about transmission? You got all the wind energy. Well, it has to go somewhere. Well, you got to spend money to hook them up and ship them around. So the transmission investment has been remarkable. I mean, this is a lot of money here. $5 billion. I'd like to have a small fraction of that. Where's wind generation? Well, looks like it's all in the West. So what does that mean? There's export of wind energy from the West going into, in particular, the region near Dallas, which is the neighboring region. And then you just keep on going. So I'll show you in the next map how they ship that wind energy all over the place. So north is where Dallas is. Houston, and south, I believe, is what, San Antonio or El Paso. So when you try to ship power across market zones, well, size does matter here. When the line is pretty skinny, power cannot go through. So there's a big issue of wind energy may get landlocked, too much power, and not enough transmission capability to ship the power out. So that actually turned out to be a pretty challenging problem in that, have you ever heard about prices that can go negative? Yeah. I mean, big negative. Not just little negative, but big negative. So they will pay a lot of money, the wind generator will pay a lot of money for someone to take the wind energy. So when that happens, what does that mean? Some other output must be curtailed. So is it a good outcome? Not necessarily a good outcome. Because what that says here is like you are disrupting some of your so-called least cost production schedule to accommodate wind generation. And anytime you disrupt your production schedule, bad things happen. Like for example, the power plant might not be working as well as it could. It'll spill out more CO2 and nitrous oxide, all the bad gases you can think of. So let's look at some of the price data here. What I did here is I plot the 15-minute wind generation output on the horizontal axis. And I also plot the market prices. All we see is like things bouncing around. And there are negative prices all the way down to what? Somewhere between $2,000 and $1,000 bucks. Yeah.
So that's odd. I've always heard that since the production tax credit was about $30 a megawatt hour, that they would pay $29.99 to get rid of it. I've never heard that it would go below $30 to do that. How does that make sense? Can you explain more about the negative price of $1,000 to $2,000?
Well, the prices are downloaded from the ERCOT file. So it's on their website. So I did not make this up. So now the next question here is why did that happen? And the things that I'm not a market expert, but the main reason given to me is that the wind generator will bid negative in order to qualify for the tax credit. So maybe Jay can help me out on this one.
West zone, it went out of -30, and this is Houston, so we may be
Well, let's see like what's going on the west side. Now, this is the west side. Yeah. So this is the west side story. So like, I mean, like there's no, I don't believe there's cogen in the west side. Do cows cogen? Maybe they do, I don't know. Yeah, but not the kind that you want. So like the west side story, how can you explain that?
So in West Texas, we had to do a business plan and set up with a large resistor, buying power and just putting it in.
I don't know enough engineering to answer that question. I flunked high school physics long time ago. So, and certainly there's like opportunities, you know, to say, if I have a lot of batteries out there that doesn't cost me money to absorb the power, yeah, you can make some money out of it. That's obvious. So, any other question that I may answer? So what it says here, I did a very simple correlation and say, look, as wind generation increases, prices tend to come down. But so what? It's only like, you know, correlation of 0.2. Is it something that, like, you know, come home and tell everyone and say, I found the magic formula. No, far from it. So to analyze how wind generation affect profitability of dispatchable generation, I use, you know, this thing called tolling agreement. So what it is you know, someone ran a machine and used its own fuel and decide to produce electricity when it's cheaper to do so than market purchase. So the agreement's expected payoff, of course, determines the buyer's willingness to pay. So if the expected payoff is getting lower and lower, the amount that they are willing to pay is getting also smaller and smaller. That will create a disincentive for investors. For those, you know, who knows finance, I apologize for the simplicity of this thing, but like, just to make sure that we are all on the same page. A simple capacity call option, what does that do? All it says is like, if the price gone up above the strike price, the option holder will exercise the option to get a payoff. And if not enough, you don't touch the thing. You don't want to buy, let's say, you don't exercise an option at $10 so that you can get at market for $5. I mean, basically, you're losing money. For a tolling agreement, the problem is a little more complicated. Because of the payout of a tolling agreement is depending on every day's fuel cost. So some days there might be high fuel cost, some days maybe low fuel cost. It bounces around. So there's no really simple formula to compute the agreement's expected payoff. I mean, I look at this formula, it's about 2 miles long, and I cannot understand it. I don't even understand a Black-Scholes model, much less a, you know, tolling agreement, you know, calculation. So, as a voodoo economist, I know one thing: regression. So let's take a look at the data first. The data always says it's like the prices can bounce around, and wind generation is very volatile, also bouncing around. So at the end of the day, all I'm going to tell you is the data I'm facing are all over the place. Oh, I have another 15 minutes, no problem. So you think the correlation between price and wind generation is bad. How about the payoff? I'm taking correlation with wind at like less than 0.1. Anyone who has done statistics would say, boy, where can I find any kind of relationship? So I always characterize this type of problem as chicken in the elephant soup. Well, where can I fish out the chicken and actually can taste the chicken? It's quite a challenge. I mean, I have a lot of data. I have over 100,000 observations, 15 minutes. So for anyone who has dealt with high-frequency data analysis, this is a mess. So now, then how can I, what is the word, that English word, tease out? No, it's not teasing out. It's grabbing the chicken out from big pot. I would go no man where would go. Stick my hand in the big pot and grab the chicken. Right. So like what I did is I come back on the last one, go back to the payoff calculation. So what I did is like every 15-minute data, I'll take the fuel cost. Okay, so let's say it's $10, and compare to the market price, let's say it's 15. So I have a $5 payoff. But what if the market price is 5? What's my payoff? 0, right? So I do this for every 15 minutes. And so like I will see a lot of zeros actually. In fact, like the tolling agreement in most of the time would have a 0 payoff about 50% of the time. And if the generation unit that I'm looking at is not a very efficient one, has high fuel costs, the amount of time that the unit would be actually in the money is less than 25%. So it's almost like C.K. Wu driving a taxi. Okay, I drive a taxi, today's fuel price, gasoline is high. And the trip is only $5 a trip. Most of the time I won't be making money. What do? I just don't even run the taxi, right? But I get lucky sometimes. The storm comes. You want to ride? Then I can make money, right? But how often does the storm come? Not too often. So does that make sense?
Yes, and then the implication of it, which is the impact it has on actual generation investment. I guess that is where you're going.
Yeah. So in order to make some sense out of this data, I would do 2 regressions. The first regression will explain the likelihood of a generator actually making any money, whether the generator is in the money. The second regression, you try to explain how big is the payoff. So the best analogies I can think of is like C.K. Wu going to the doctor's office. Will it work? The doctor says, yeah, sure, it will work. But how good will it work? The doc probably say, very well, right? So, and looking at a data file that has like over 50% of your data are zeros, it's very tough. I mean, try to figure out, like go home and try to do your little regression and put half of your observations as zeros and try to find out y equal to a plus bx regression, you'll get a really funky answer. So anyway, after I've done the regression, then I say, okay, now let's do some simulation. Simulation in the sense of like, I ask the question, what if the wind generation had been 10% higher than historic level? Make it 20%, make it 30% higher, make it 40% higher. Then the way I calculate expected payoff is like the probability that the generator actually getting a payoff times the size of the payoff. So that will give you the expected payoff. Because when you take the probability of no payoff times a zero payoff, that part is just zero. That doesn't matter. So after I bum around and make all the calculation, the first thing I need to check is are my regressions making any sense in the first place? So what I found is like, sure, increase in wind generation reduce the probability of strictly payoff and the size of that payoff. And the same thing, if you have more nuclear, an increase in natural gas price, that's really interesting. On one hand, it reduces the payoff because of the increase in fuel costs. At the same time, it can also have the price effect because you jack up those people, those generators in the market, they will get their higher bid. So there are two sets of effects going on. And of course, increase in demand will increase the payoff because it raises the market prices. Oh, all the detailed results are in the appendix. And I don't want to bore you with it because Varun said, no, don't talk about those. And I follow the leader. Okay, key findings. "20% increase in wind generation probably won't change the picture of profitability too much. Yes, it will come down, but not to the point that it is statistically significant or large in size to worry about. Is that a reasonable number? Well, so far, I look at some of the regions that had 10–15% renewable energy and wind. The market seemed to be okay. Okay in the sense there's no significant outage, there's no significant drop in prices. So that seemed to be okay. So it kind of nice finding. But once you hit 40% increase, you start seeing substantial drop in profitability. So this becomes a dilemma, a big dilemma. On one hand, you like to see wind generation for all sorts of reasons. Because I'm environmental supporter, or I just believe in clean energy, or for whatever reason, there may be the government want to have more jobs, God knows what. But the point is, let's say you want to push wind generation more and more. But in order to make wind generation workable, because it bounces along, up and down, it can a lot of output or become zero in the next minute, you need to have complement of dispatchable thermal generation. And yet there's this decline in profitability. How do you attract them to come into the market? Well, as I talk about the alternatives at the beginning of my talk, let's say we adopt any one of these. That also raises the issue about, how does that reconcile the philosophy of market restructuring, let the market decide, let the competitive market decide on a lot of things. So it brings back to a more fundamental philosophical issue. Is wind generation development necessarily consistent with market restructure that's supposedly to introduce competition? So this debate has been going on for about, what, I would say at least 7, 8 years. There's always been this debate. Is reliability requirement? In this case, it's also a reliability issue. Is it really consistent with a pure market competition model? Or can we amend this so-called pure market competition model with something else? For example, can we do, let's say, make all the demands controlled by the system operator? So if there's no wind, no energy for you. Would that work? I'm not so sure that will work. I will be very unhappy. It's cold and the wind is blowing hard. I want my electricity blanket. Don't shut me down. So this is an ongoing, very major problem. It's the engineering reality meets naive economists. I don't say this lightly. In my company, I'm the only bozo economist. So, and I've been talking about this for many years, and I got laughed out the door. So, but anyway, the point being that if one is more careful about the engineering reality of life and how customer would prefer reliability, well, yes, you can do wind generation. I have no problem with that. Yes, but you need to do something about it. In that, you may need to put a little bit more transmission. You might need a little bit of dispatchable generation in order to integrate wind generation in the system. Now, that can all be done. The next question is show me the money. How much does it cost? The next question is who's paying for it? I'm all for it, especially I'm not paying for it. I'm very generous with your money. So anyway, these are some of the things that we think about. So yeah, what's next is, again, this is a throwaway slide in that I've written my paper. I don't know what to say next. Oh, okay, I throw in some kitchen sink. So, no, I was forced by the editor to say something. So the point is, at the end of the day, what I describe here, can I use the same approach to deal with the next step in ERCOT? Probably, yeah. Once you got more data, I can pound it through and tell you what the outcome might be. So anyway, that's the end of my talk. And here are some of the references. There's plenty out there. And so you notice that the winds are changed. So there's a Gone with the Wind. So I got to have fun of title that otherwise it's not sexy. So Blowin' in the Wind. Thank you.
We will open up for questions. I need 2 student volunteers, one on that side, one on this side, to pass around the mic. 2 student volunteers. And I'll start with the question here.
Over the past year, and as far as I see in the coming year, most of the wind generation, new generation being developed, is coming from the coastal winds, onshore coastal winds, going into the South Zone and the Houston Zone. And two things about that. First, the profiles are much less volatile than the western winds. And secondly, there's more transmission capacity in the south zone going in there. Do you have any thoughts of how that impacts this? It seems to me that, and it's cheap, it's 4-cent wind that's coming out of there. It seems to me that would even exacerbate the problems you're talking about even further in the market. Do you have any thoughts?
For one thing, you know, I don't think anyone would dispute either, you know, kind of intuition or empirical fact. When you have more wind, the market price will come down. You know, then I think if it's coming, you know, from offshore and it's persistent wind, that means that you have more days that the generator is out of money. You know, and it just makes it more difficult to accommodate wind generation. So, and I think like Houston is the region that is not really self-sufficient. So that, to answer your question, yeah, you will make it more challenging.
First of all, thank you very much for this unique presentation. I have heard about lots of study promoting renewable energy and wind energy, and this is another aspect. My concern is that is there any study concerning the other markets like ancillary services and the capacity market which can be supported for this thermal energy investment? I mean, those markets is just energy markets. People are selling their energy on the row of their marginal pricing. Of course, if you are producing energy in less cost, you can reduce the market price. But on the other hand, there are another markets like capacity and the ancillary services. Do you think those mitigation in price of this thermal energy can be compensated by the other markets like capacity and the ancillary services? Is there any study like that? Thank you.
No, I have not seen a detailed study on that. No, certainly the talks are there, but the trouble of relying on ancillary service market like spin selling reserves as a way of obtaining revenue, that is not going to make it. Here's why. An electrical system is planned to have reserves. So the typical amount of reserve planned is 10 to 15% of the system peak. So now if you're selling capacity reserve on a day-to-day basis, you already got, you know, quite a bit out there because it is planned. If you look at the spinning reserves or like non-spinning reserve, you look at the California market, the day-to-day reserve prices, they are very low. You're not going to make it in terms of getting enough dollars to pay for your idle plan. So the only way that someone would enter the market and put up hundreds of millions, put in a little generator that doesn't run most of the time, is to have a long-term contract. Otherwise, not even like, you know, Fannie Mae would finance it.
Yeah. So, as I understand it, your tipping point here is when wind becomes the marginal generation above a certain amount of time. That's when you start to see these strong effects on depressing the price, and so you can't make money. So I'm wondering if you think this through, if we sort of tease it forward in time in a place like Texas where we don't have capacity markets, we're entirely relying on nodal prices to provide incentives to build. So if that starts to happen and people don't invest, then we have shortages in some places, and so the nodal prices should go up, right?
Mm-hmm.
And then theoretically anyway, that should provide an incentive either for people to build closer to the load or for people to have incentive to reduce their consumption, at these high price nodes.
Right. That's the problem when we say theoretically.
Right. So how do you see this playing out over time with this incentive to build being reduced? How do you see it playing out in a place like Texas where we're apparently not going to have capacity markets here?
Yeah. Well, if that's not the case, then you will have some other way of dealing with it, in that we know we need additional capacity. That's a given. If we don't accept that, then all bets off. So let's say we accept that premise first. The next question is how do we get there? Must that capacity be transacted in an open market operated by ERCOT? The answer is no. It doesn't have to be that way. So let's say CK Wu, Little Muni, with CK Wu the only consumer, I went out to, and bought some wind energy. So I will go to, Professor Spence had a little, generator at the back. I say, come on, sell me some. You don't use it that often. That's outside the ERCOT operation, actually. I just self-insure. But that is it really a good outcome? I'm not so sure that's a good outcome. So, and that's why, sometimes it's it is a little bit more efficient, to have a, big operator buying the reserve. So is it really something that, can be done? Yeah, it can be done, obviously, because it is being done right now. But is it really consistent with the notion of energy price alone, a competitive market with energy price alone, will be adequate to lead to optimal investment in capacity? That presumption, I think a lot of people would have problem with it, because I have problem with it on a very simple basis. It runs as follows. Let's say CK were thinking about buying a little generator, something like this. And you run maybe like this much of the time. And I may get lucky, to be sure. Now, remember, the generation unit will last, 15, 20 years? And I have to count on getting lucky every year, enough times. Can I count on that? Will any bank even finance that? Can I collect any dollars from here to finance that? If you know, CK Wood's revenue is like this. 0. And I need to figure it out for the next 20 years. Would you? I'd like to see you invest in my company.
Hi. My name is Michael, and my question is directly on what you're talking about as far as the market being the right mechanism, the free market of pricing structures to be the one that's making the decisions in terms of what direction our energy policy is going, but also addressing the fact that we don't really have a coherent energy policy at all as far as moving us more towards renewables and away from other types of generation that are based on fossil fuels. So how do you see a better energy policy forming even on the national or global level to address the inadequacies of the free market to solve our problems for energy?
Well, I think I know this is a landmine to answer. No matter what answer I give, I'll piss off a lot of people. Because if I say it's integrated resource planning, then your point to me is he is a pinky, central planning. Right? That's very problematic. So, but I can only tell you the California experience. That's the one I'm most familiar with. What happened there was that we did the restructuring. Of course, it blew up. Total disaster. After that, we pretend that we have a competitive market, but everything is back to centralized planning, in that the government actually will tell the utility, that's how much you need to buy, that's what you need to buy. Now you go on and do competitive procurement. Competitive procurement is like, CK, we want to have a cup. Who can sell the cup to me the cheapest? That's about it. So is that really still a competitive market? I'm not so sure. So now, on the renewable energy development target, in California, there's a law. 33% of retail consumption must be met by year 2020. So that was the law. Everyone need to comply. You don't comply, you go to jail. And Jerry Brown will send you to jail, right? So the utilities out there would just scramble and buy whatever, how crazy that might be, just sign up all the renewable energy deals. Is that a good outcome? I'm not so sure. So like when we say, do we want to have everything by government decree, like this 33% by year 2020 target, just set it without knowing how much cost. Just set it. So that's heroic, right? And heroes die young. Yeah.
Quick follow-up. Quick follow-up is, I mean, there's other way to do it. You could do it with a carbon tax and a renewable energy incentive, which just adjusts the prices little by little instead of being a big mandate.
Yeah. As I said, like, I'm not, really, I have not done a lot of work in the carbon pricing or market design work, so I would defer to your expertise.
Yeah, just quickly, when you were saying that the increased wind capacity will create a disincentive for generation via combustion, does that at the same time create a positive incentive for electricity storage?
How can that be? I mean, when price come down, you try to get more supply? Interesting. I don't think anyone would, when I say like, when prices crash, supplies cannot increase. It just doesn't make sense.
But if you're buying electricity to store in batteries, for example. And
have you checked the battery cost these days? I think your car battery is pretty expensive, and those that can be actually store electricity for the next day use, they're even more expensive. So that doesn't work. Again, it's like technologically, a lot of things can be done. It's still coming down to how much, who is paying for it. If we're willing to pay a lot of money, like California, the retail electricity, like I'm paying almost 40 cents a kilowatt hour. That's probably twice or 3 times what you are paying. So then the next question is like, is it worth it? Obviously, Californians, though, at least the regulators think that, yeah, it's worth it. That's why you're paying it. So, yeah. Thank you. Yeah.